Welcome to this third part of the lecture series on processing of a fabric on a Stenter. In this lecture, we are again going to cover two aspects of processing a fabric on a Stenter. The first point that we will be discussing is about different gripping elements or devices that are used on Stenter chains to hold the fabric salvages. The other thing that we will be discussing in this lecture is related to the controls and calculations for adjustment of fabric width on a Stenter. So as it has been mentioned before, the fabric is passed through a Stenter in completely open width form and in a situation where only its salvages are secured. So the salvages are secured in what we call Stenter chains, and chains run along the entire length of the Stenter on either side of the machine. So what you're looking at here is a simplified view of a Stenter. Let's consider that the fabric is entering from the right hand side of this image, and then it's leaving from the left hand side of the image. So this is the direction of movement of the fabric through the machine. Now the Stenter chains are provided on either side of the machine, and they run along the entire length of the machine. The gripping elements that actually hold the fabric are mounted on these chains. Before we look at the different types of gripping elements that are used, let's watch a short video to give us an idea of how the gripping elements hold onto the fabric salvages. So again, this is the gliding mechanism, the entry of the gliding mechanism. And you can see that these gripping elements are continuously being fed on a chain, and these gripping elements hold onto the fabric salvages as it is passed into the treatment chambers. Now these gripping elements here can be of different types, which we are going to discuss about in the next slide. Let's have a closer look at the different gripping elements and what difference does it even make. So the two different types of gripping elements that can be used on a Stenter are called pins or clips. So if the gripping element is the pin type gripping element, then it will look something like this. The essential part to focus on is this bit, which is actually just a bed of pins. And it comes in different profiles, and according to the type of fabric that you want to process, its GSM and other properties, you can select the right type of pin bed. The advantage or the main feature of using pins as the gripping element is that with the help of pins, you can do excessive overfeeding of the fabric. So this is how it looks like. If you look at it in a schematic diagram, the fabric is aligned onto the pins, and then a brushing roller, which you can see over here, just simply presses the fabric salvages into these pins. And the way this whole action works allows us to put more fabric on the pins in the lengthwise direction. So the fabric tension in the lengthwise direction is 0. So as mentioned, excessive overfeeding is possible in pins only, and this will allow you to increase the width of the fabric. On the other hand, if we want to run or process a heavy GSM fabric on the Stenter, then we need stronger gripping elements. And for this, the type of gripping element that we use is the clip type gripping element. This is how a clip looks like. And if you want, you can pause the video here and go back to the previous slide and look at the gripping elements that are shown in that video again. And you will realize that in that video, it's the clip type gripping element that are shown. So the clip essentially consists of a flat base plate and then another lever type plate, which is lifted or lowered to grip the fabric. So basically the fabric salvage is gripped between these two metallic parts, the base plate highlighted in red and the top plate, which is highlighted in yellow. So because it's a metallic grip between two flat surfaces, we cannot overfeed the fabric, otherwise there will be permanent creases in the fabric. And that is essentially the main difference between pins and clips as gripping elements. So now that we understand how exactly fabric selvages are secured in a Stenter, we can talk about how we actually adjust the width of the fabric. So to adjust the width of the fabric, the gap between the chains that are provided on either side of the Stenter and are running through the entire length of the machine can be adjusted at multiple points along the length of the Stenter. This is done with the help of devices that are known as chain track guides. So let's first see where the chain track guides are located. Again, you have this schematic of a Stenter frame in front of you, and the chain track guides are provided at multiple points along the length or in different treatment chambers. So in this example over here, I've shown 6 chain track guides, but depending on how many treatment chambers are provided in a Stenter, the number can vary. The point that needs to be understood is that there are multiple chain track guides, that is, there are multiple points at which we can adjust the gap between the Stenter chains. So if we look at again another schematic showing the internal structure of the treatment chambers, then as mentioned in the previous slide, the chain track guides are provided at different points in the treatment chambers, and they are not visible from the outside. So they are basically located inside the treatment chambers. So here in this image on the right hand side of the slide, you can see in the two red circles, I have highlighted the chain track guides. These are basically sort of clamps that are holding on to the Stenter chains. And these chain track guides can either be moved away from each other if we want to increase the gap between the Stenter chains. We will need to increase the gap between the Stenter chains if we are trying to stretch the fabric in the widthwise direction. And of course, the chain track guides can be moved towards each other as well if we want to relax the fabric in the widthwise direction. And given the fact that we have these multiple points of control along the length of the machine, we can gradually increase or decrease the width of the fabric as it passes through the treatment chambers. So to better understand how fabric width is adjusted with the help of chain track guides, let's look at an example. So let's suppose that we have an incoming fabric width of 100 inches and it is required to increase the fabric width to 104 inches. Let's assume that the total number of chain track guides that are available on the Stenter that we are going to use for this purpose is equal to 7. We are usually given certain conditions that we have to achieve. For example, it might be required to maintain the final width of the fabric in the last two chain track guides. This is usually required to give the necessary dwell time for the processing conditions to have a permanent effect on the fabric characteristics that we are going to alter. So if that's the given situation, then the actual number of chain track guides that are available to us to increase the fabric width by 4 inches is actually 5. Recall that the total increase that we are aiming for in the fabric width is 4 inches. Using this information, we can calculate how much fabric width can be increased on every chain track guide. It is important to understand that the overall change in the fabric width that we are trying to achieve cannot be achieved in a single step. So it has to be done gradually. And that is why we try to distribute the overall increase in the fabric width or decrease in the fabric width over the number of chain track guides that are available to us for this purpose. So in this case, we can calculate how much fabric width we can increase per chain track guide. So the total increase that is required divided by the total number of chain track guides that are available to achieve that increase, that is 4 divided by 5 in this case, which is 0.8 inches. This means that in this particular case, on each chain track guide, we can achieve an increase of 0.8 inches in the width of the fabric. Let's now look at this calculation visually. So we have, let's say, a simplified view of the treatment chambers, and the vertical lines that you see along with their numbers are the chain track guides, as you would have probably guessed already. So as it was mentioned in the previous slide, There are in total 6 chain track guides available along the treatment chambers in this Stenter. The incoming fabric width is 100 inches, and at the exit of the Stenter we want to have the width of the fabric increased to 104 inches. So as the fabric enters into the Stenter, its width is gradually adjusted along the length of the Stenter on chain track guide number 1 all the way up to chain track guide number 5. So as we saw in the previous calculation, on the first chain track guide the width can be increased to 100.8 inches. On the next one, another increase of 0.8 inches to make it 101.6, and so on, all the way up to the chain track number 5, on which the fabric has achieved a width of 104 inches. As it was mentioned in the example scenario, we are required to maintain the fabric width in the last two chain track guides at 104 inches exactly. So this is how the fabric width is maintained, and at the output of the Stenter we have this fabric which has a width of 104 inches, and the width has been set because the necessary dwell time has been given. Let's look at a summary of what we have discussed in this lecture. So in a Stenter, the fabric salvages can be secured on pins, which allows us to do excessive overfeeding of the fabric, or the fabric salvages can be secured on clips if we require greater holding force, as in the case of heavy fabrics. Some textile processors do claim that they can achieve some overfeeding on clips as well. The other point that we have discussed in this lecture is that fabric width is adjusted on a Stenter by means of chain track guides that are provided at multiple points along the entire length of the Stenter. Usually, width adjustment is done gradually. So if you want to increase the width of a fabric by, let's say, 1 inch, you will not do it in one step. Instead, you will do it gradually. And while doing this, we have to ensure that we give the fabric enough dwell time in the treatment chambers so that the adjustments are permanently logged. Thank you for listening to this lecture, and in the next part of this lecture series, we will discuss the construction and the process control in treatment chambers.